The next thing we have to figure out are horizontal asymptotes, or in this case, there'll only be one. Potentially there could be two, but for a rational function, there's only ever one. So a horizontal asymptote is a horizontal line that the graph doesn't cross out on the edge. Technically, toward the middle of the graph, you can cross the horizontal asymptote, but when you get far enough away from the y-axis, then you just approach it. Okay? So at the ends, it doesn't cross it, it just approaches it. So here we go. The line y equals b is a horizontal asymptote Make sure you're careful how you abbreviate that, by the way. Of f, if the limit as x goes to negative infinity of f of x equals b, or the limit as x approaches positive infinity of f of x is equal to b. So if it just approaches a number, when you get far enough away, that number, y equals that number, would be the horizontal asymptote. Now, there are several cases that determine where the horizontal asymptote is, if there is any horizontal asymptote. So, let's endeavor to understand how that works. So, for demonstration purposes, let's say that f of x, since this is polynomial over polynomial, what? Sure. So, again, for demonstration purposes, let's say that f of x is an x to the n plus an minus 1 x to the n minus 1 plus dot 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 plus a2x squared plus a1x plus a naught. We all know that's a polynomial by now, yes? Over bm x to the m plus bm minus 1 x to the m minus 1 plus dot 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 plus b2x squared plus b1x plus b naught. So in other words, that's a different polynomial on the bottom. And since I used a different letter, it doesn't necessarily have to have the same degree. So obviously the degree of the numerator is n and the degree of the denominator is m. And in this setup, an cannot be 0 and bm cannot be 0. Thank you for not laughing at that. Because that would have been pretty crappy. That wasn't funny. Anyway. So, in order to understand the nature of the horizontal asymptote, we have to look at the degree of the numerator and the degree of the denominator. So, there are three possibilities. First, let's say that m is greater than n. So in other words, the degree of the denominator is bigger than the degree of the numerator. Well, the bigger the degree, the faster it grows when you get out toward the edge, right? So if the denominator is growing faster than the numerator, so if the bottom of the fraction is getting bigger way faster than the top of the fraction, what's going to happen to the fraction? It's going to get smaller. And in essence, when the denominator gets huge, what number is that fraction going to approach? 0. Indeed. So that means that when you get out toward the edges, so if x gets really negative or really large, the denominator is going to dominate, and it's going to make this shrink down to 0. Therefore, if the degree of the denominator is greater than the degree of the numerator, then your horizontal asymptote is y equals 0. Ha! So let's examine the case if n is equal to m. So that would mean that the two degrees are the same. So that would mean once you get out far enough, this an x to the nth and bm x to the nth are going to grow at the same rate. And you're not going to have to worry about all this other stuff, because if you remember back earlier in this section, once you get out far enough, that leading term is going to dominate, and that determines your end behavior, right? So, if these grow at the same relative rate, that means that eventually they're going to get big enough where you can ignore all this other stuff, and you've got an x to something over bm x to something, and those x to somethings are the same, so they essentially cancel each other out, and you end up with an over bm. So, if the degrees are the same, the horizontal asymptote is the ratio of the leading coefficients. Y equals the ratio of the leading coefficients. The only other case we have to consider is if the numerator has higher degree than the denominator. So let's go back up here. So if the numerator has higher degree, that means the top of the fraction is getting bigger way faster than the bottom. So what's going to happen to the fraction if the top grows way faster than the bottom? It's going to get huge, either in a positive way or in a negative way. And in fact, it'll either go to positive infinity or negative infinity at that point. Well, in order to get a horizontal asymptote, you'd have to approach a number, right? You'd have to level out toward a horizontal line. Positive infinity and negative infinity, those don't do that. So therefore, if the numerator has higher degree, there's no horizontal asymptote. Make sure you study that and know it. Because honestly, there's a chunk of the test where you've got to identify all this stuff, and if you get stuff mixed up, you're literally going to hemorrhage points on that part of the test. Nobody likes a hemorrhage. It's bad for you. Okay. Now, let's do some examples. So let's say that f of x is equal to 4x over 2x squared plus 1. By the way, there are no vertical asymptotes because you've got something x squared plus something else. Remember, that's not equal to 0 in the real numbers. But let's look at the horizontal asymptote, shall we? Is there a horizontal asymptote? And if so, what is it? Yeah, so if that's the case, then what's the horizontal asymptote? It's more than 0. What? No, it's y equals 0.
Yeah.
0 is a number. Y equals 0 is a line. I'm going to be extremely picky on that, yes?
Why did you say it's not a vertical asymptote? Like, how do you tell the difference?
Remember that division by 0 causes vertical asymptotes as long as there's no common factor. And what I was saying was, if you square a number, you end up with either 0 or a positive number, right? And then if you add 1 to it, you're going to end up with a positive number. So this thing right here is never equal to 0. Therefore, there's no vertical asymptotes in this. Yeah, basically what you could do is you could set this bottom part equal to 0 and solve it, and you'd end up with I square roots of 1/2, plus or minus, obviously. And since that's imaginary, you don't have to worry about any vertical asymptotes. Okay. So what can you tell me about this one? All right, so the degrees are the same. And if the degrees are the same, I'd end up with y equals so the leading coefficient in the numerator is 4, and the leading coefficient in the denominator is 2. So 4 divided by 2 would be 2. And the reason why I wrote it like that at first is that emphasizes to you where this 2 comes from. It doesn't come from the degree. It doesn't come from this 2 right here. It comes from 4 divided by 2. So what can you tell me about this one? It doesn't have a horizontal asymptote because the degree of the numerator is higher. Now that's not to say it doesn't have an asymptote, because it does. What happens is, if the degree of the numerator is 1 bigger than the degree of the denominator, then you get what's called a slant asymptote. It's an asymptote that's not vertical, it's not horizontal, but it's slanted. And how you find it is you actually do the division. And since I only have 1.5 minutes, I'm going to do the division off camera. So abruptly, there's your division. And so this part right here, this piece right here, as x gets really big or really negative, the denominator has higher degree than the numerator, so this piece is going to go to 0 when you get out toward the edges. So what happens is, that means that your function, when you get out away from the y-axis, is going to approach that piece right there. So y equals 2x is the slant asymptote. So basically, if you graph the line y equals 2x, then when you get out toward the edge of the graph is going to approach that line. If your degree were 2 bigger in the numerator than the denominator, then it's going to approach something that looks like a parabola on the edges, because that would be degree 2 bigger. Kind of neat.